recording. Okay, so if I've done this right, I am now recording on my own personal recording device, not the classroom one. So what I'm going to show you is a complex setup. It introduces something new, an Arduino. Okay, but some of you may or may not have seen this thing in the Tinkercad, but this is a microcontroller that you program. And before the end of the year, we're going to be getting to this. So I'm introducing something new. It's a thing that you can program that will do stuff. And what this is doing is turning something on and off. This is called a relay. And this is a switch that turns on and off when this Arduino microcontroller sends a signal to it that says, turn on, turn off. So, how might this work? I am going to try to turn my Arduino on. Oh no, I got the wrong thing. Well, this is, oh no, it isn't. I have the right thing. I need a nice big desk where I have all kinds of stuff at the same time. So, here we go. Here's the thing that I need. Well, this video is going to be it'll be just like Hubbard in the classroom, doing stuff, having trouble. Well, that's engineering. Okay, this is a plug. This plug is hooked into a transformer that's plugged into an outlet. When I put it on here, this thing turns on. Okay? This is a special kind of switch because the switch is turned on so that when I press this button, you should see a light blink. Okay? Now, here's what's interesting about this. Now, remember when I had the coil. Oh, I'm going to do this tomorrow. I'm going to be so much better. Remember this coil, right? And remember when I put this thing inside the coil? Oh boy, it melted and this coil melted. Remember I had this thing in the coil, and when I put a current on the coil, which I don't have right now, this thing moved. Let's see if I can actually make that happen. I'm not sure that this is going to work because I had so much current going through that coil at one time, it melted. You can see that it's bent. And I don't think this is going to do it, but it might. Let's just see. No. I need more current. I'm not going to do it. But anyway, I'm hoping that you remembered. Do you remember that happened? I put this when I put more current. This is bent, so it's stuck. See, it won't come out. So I got to get another one, and it shot out. Somebody say yes. I can only see one or two faces. So you guys remember. Let's go. Everybody remember. Say yes all at once. I want to hear a whole bunch, except for Amina, who can't talk when she's eating. Okay, very good. Thank you. So, what's happening here, I don't know whether you remember, I told you these things, they get hot, and this thing actually melted. So, I didn't think I was going to do this. So, what we have here is this. This thing is actually plugged in to a transformer that takes this is the exact same thing. There's a coil. See that blue in there? That's just covered up. That's a coil inside. And so when I plug this thing in and it turns on, the current goes through the coil and it is an electromagnet. And like that piece of metal that got pushed out when I had that other thing, this gets pushed out. Now, when I touch this switch, it's going to send a signal through the Arduino and it's going to turn it off. So this is the thing, when you touch the switch, see this light over here? This light goes out and this light goes on, and what it's doing is it's taking the current that comes in here, and it's either allowing the current to go over here or not. And when I push the switch down, the current is going through here, making this an electromagnet, and it goes back. Then when I lift up, actually it's the other way. When I lift up, the current is going through here, and when I push the switch, the current is turned off because it's the way it works. And this spring, see how the spring pushes this thing back? Are you kind of following what I'm doing? I mean, you're seeing it. You can see that it moves. The spring, when the electromagnet turns on, it pushes this against the spring, compresses the spring, and turns it this way. When I turn the current off, there's no current, there's no electromagnet, there's no nothing. This thing, the spring pushes it back. And so this is like an electromechanical device that actually has a little computer program that's doing something in this relay. And all of this that I'm showing you is because next class, remember I told you I was going to show you something new and then we're going to go back to the old. Right in here, let me get a red. Okay, right in here. I got to turn this so you can see it. Let's go. We can do this. Right in here are two little boxes. Can you see those two little boxes? Yes. Guys, you got to talk to me. Make noise. Go, yeah. You know, if you were in a classroom, you know, you'd be, okay? This thing is really cool, which is why I want to teach it to you, because inside this little box is a teeny-weeny device that takes what's the equivalent of a beam of light, and it sends it from there's an air space in the middle. I can't take this apart, it's too small, but I've taken these apart, and I'm going to show it to you next class. There's an air space in here. And like this thing, when I press it, it turns the current on or turns the current off, and I'm doing this. Inside of here, a little light beam goes from this side, which is the 5-volt Arduino side, and it sends it through there and moves a switch inside of here, which then connects a 24-volt current that's in this wire here that's connected, plugged in, but it's 24 volts, and makes this work. So in other words, this thing right here needs more voltage than this Arduino can handle. That's the whole idea. This is how a small, simple 5-volt microcontroller that would burn up, literally burn and smoke. If I plug one of these 24 volts, it would smell bad and it would start to smoke. I'm not doing it. They're expensive. So by having this relay that takes a 5-volt signal, turns an electromagnet that's inside of here that we're going to show, and makes a connection, so it completes a circuit, it allows this 24 volts that's coming through this wire to make a connection to drive this. So this is turning on this, which is turning on this, which turns on this and makes this move. Are you all dizzy and have headaches, or you're sort of following what I'm saying? So this is like a complicated thing. This switch is enabling this to send a signal that's going to this, that has something happen inside of here, which then has something else happen inside of here, which makes a connection that allows 24 volts that would burn this up, operate this. Somebody raise their hand and tell me what they think about all this. Is it too complicated? Is it interesting? Do you want to kind of understand more? So, Casey, what do you think? Because I can see your face. Give me a reaction.
Oh, just a reaction, okay.
No, I don't. Just use words. Is it interesting? Would you like to?
We've been interested in like microchip starting and stuff. I always thought they were pretty cool.
So you kind of understand that this microchip that you would burn up if you put more than 5 volts into it, it's a way, this relay is a way that you can make your microchip do something with a higher voltage. Got it? Okay, Amina, what about you? Just don't shake your heads. Use words. Tell me what's going on in your head. Is it interesting? Is it confusing? Do you think you'd like to be able to understand more about what's going on here?
It's interesting and I get it.
Okay. Now I got 2 other people. I know what you're going to say. Valentino, where are you at with all this?
I think it's cool. But I have a question.
Sure.
So is it like an energy dampener? Or like does it decrease the amount of energy? Or
It does neither. Now the plug that I plug in, which has a transformer, is taking household current, which is 110 volts of alternating current, and transforming it into, well, one of them is 12 volts. That's the one I plug in here. And this one is 24. So it's taking alternating current of a very high voltage, transforming it into less of direct current. And then inside of this microcontroller, it's taking 12 volts and toning it down to 5 volts. So yes, it's transforming. And I'm going to show you eventually a transformer and teach you how transformers work. So when you say increasing or reducing energy, I mean, it all ends up being equal, but it transforms it. Does that help answer your question, Valentino?
yes.
Okay, Juliet, I know what you're going to say. You're going to go, oh man, I'm loving this stuff. But,
Yeah, it's cool that if you could explain more about it.
oh, you're gonna. It's all, I mean, this is how most of the stuff, or a lot of the stuff that we have in our lives that we take for granted, work. Is we come into these computer chips and programs and microchips and things, and they take an input voltage and they play around with it and they distribute it and send it to things, and then the things that it's sent it to does things, and one thing does something, then something else does something, and all these different things are doing different things with electric current going all over the place and making stuff happen. Mina, talk to me.
I additionally think that this is a really interesting topic. Like ever since I was little, I've always wanted to know a lot about this. And now that I am, I'm really grateful.
Okay, and do you guys all agree? I want to hear a roaring, everybody turn on their mics and agree. If I can figure out, I'm going to stop. I've been recording everything that I'm doing. I'm going to stop if I can. Hold on.